Numerical solutions of equations. Solutions of an equation are nothing but the points where the graph intersect the x-axis. For this graph, the solutions are x equal to 2 and 3. When x equal to 2 is a solution, all the y values above the x-axis are positive and the y values below the x-axis are all negative. So automatically when there is a solution, there is a change in sign in the y values. So using that concept only we are going to do that. We'll find out the y values. Suppose if we substitute the value for x as 1, you will get your answer as positive. If you substitute the value for x as 2.5, we'll get our answer as negative. So when it is a 1, it is positive. When it is a 2.5, it is a negative. That means there is a root between 1 and 2.5. This is how we are going to solve the questions using the numerical solutions. Now the first question, show that f of x equal to sin x has a root in the interval pi by 2 less than x less than 3 pi by 2. So first what we do is, for this solution, we just find out the minimum value, that is f of pi by 2. When you do it, just substitute it, sin pi by 2 when you take it is a 1. The same way, f of 3 pi over 2, that will be equal to sin 3 pi over 2. So we get our answer as negative. So we need to write this as there is a change in sign between f of pi by 2 and f of 3 pi by 2. There is a root of f of x in the interval pi by 2 less than x less than 3 pi by 2. Writing the statement is very important. If you don't write that, then you will not be getting the full marks for this question. Now the second question, show that the roots of the equation 7 plus 5 over x equal to 13 over x squared lie in the interval 0.95 less than x less than 1.1. Now you see that we have two sides of the equation. So we'll first shift it to one side. So it will be 7 plus 5 over x minus 13 over x squared will be equal to 0 when we shift it. This is the solution. Then the next step is we write this as f of x. Whatever we get, we write it as f of x. That is 5 over x minus 13 over x squared. Then we just find out the value for f of 0.95. When we substitute the value for x as 0.95, we get our answer as minus 2.141. In the same way, f of 1.1 when you substitute, you'll get your answer as 0.802. So the final statement has to be written as there is a change in sign between f of 0.95 and f of 1.1. There is a root of f of x in the interval 0.95 less than x less than 1.1. So we have showed that there is a root in the interval. In the first two questions, we have found how to check whether there is a root present in the interval. Now this iterative method is used to find that particular root in the given interval. First question, show that one root of the equation x squared plus 4x minus 7 equal to 0 lies in the interval minus 6 less than x less than minus 5. B part, show that x squared plus 4x minus 7 equal to 0 can be written in the form x equal to a over x plus b, where a and b are constants to be found. C, find the root of x squared plus 4x minus 7 equal to 0 in the interval minus 6 less than x less than minus 5 to 2 decimal places. So in this question, we are going to find the exact root which is present. The first part is like the first two questions. So we just write it our equation as f of x. So it will be equal to x squared plus 4x minus 7. Now our first thing is we find it out what is f of minus 6. When you simplify, you get f of minus 6 as 5. In the same way, the other value is f of minus 5. You get it as negative 2. Now we see that there is a change in sign. So there is a root in the interval minus 6 to minus 5. Now in the second part, we need to write this given equation in this form. In order to write this given equation in this form, we'll keep x square on one side and all the rest we'll shift it to the other side. So x square will be equal to 7 and this as minus 4x. Now we divide this entire equation divided by x. So when we divide this entire equation by x, x squared divided by x will give us an x. This will give us 7 over x and minus 4x over x will give us a 4. So we have written in the form. So in this case, when we compare, our a is 7 and b is minus 4. These are the values, constants in our form. The C part of the question, we need to find the particular root. That is, we have to find an answer for x in the interval from -6 to -5. So in order to do that, this equation which we have found in the B part, we add some subscripts. So we write here x as xn plus 1 and here it will be xn. And then we take our interval. So we just take x naught will be equal to our -5. So the first value will be taking it as x naught. So in this, we'll substitute n equal to 0. When we substitute n as 0, this 0 plus 1, so we get it as x1. x1 will be equal to 7 over x naught minus 4. And we already have our x naught as -5 minus 4. So when we simplify this, we get it as minus 5.4. And then next thing is we substitute n equal to 1. So x2 will be equal to 7 over minus 5.4 minus 4. That will be equal to minus 5.2963. Always it is better to write all these values to 4 decimal places. The final answer only you'll write to 2 decimal places. Then only 2 of them you show the working. Then the third one onwards, you can just directly write out the answers. x3 will be equal to minus 5.32168. Then x4 will be equal to minus 5.31537. Just use your calculator. Then x5 will be equal to minus 5.31693. So when you take over here, we are getting our answers correct to 2 decimal places. So when we take over here, we are 5.32. And here also the same way. When we round up, this also comes as 5.32. So it is enough if we stop over here itself. So our value for x will be equal to 5.32, correct to 2 decimal places. That is, we have to proceed until our value gets repeated. No need to find this x5 value, only up to here. Since we have got our answer as 5.32, our final answer will be minus 5.32, correct to 2 decimal places. The second question, the sequence of values is given by the iterative formula xn plus 1 will be equal to 2xn over 3 plus 4 over xn square, where x1 equal to 2 converges to x. First part, use this iterative formula to determine alpha correct to 2 decimal places, giving the result of each iteration to 4 decimal places. Second part, state an equation that is satisfied by alpha and hence find the exact value of alpha. Here using the iterative formula, what we find is an approximate value. So here we have to find the exact value. So now our iteration formula which is given is x n plus 1 will be equal to 2xn over 3 plus 4 over xn square. Now our first part, it is given as x1 equal to 2. So one value, this n has to take a 1, then only you'll get it as 1. So here it becomes n we take as 1. So it will be equal to 1 plus 1 is x2 will be equal to 2x1 over 3 plus 4 over x1 square. So it will be equal to 2 into 2 over 3 plus 4 over 2 squared. So when you do it, the answer is 2.333. We have to give every answer correct to 4 decimal places. So now we need to proceed until we get a repeated answer. Now this one we have done in a previous part. Now we'll take the value for n equal to 2. When n equal to 2, we get it as x3 will be equal to 2x2 over 3 plus 4 over x2 squared. So we just substitute this value wherever there is an x2. We replace this 2.333. Here also the same way when we replace it. That is 2 into 2.333 divided by 3 plus 4 divided by 2.333. 4 places the whole square. So when we simplify with the calculator, we get it as 2.2902. Here for 2 decimal places, our answer is 2.33. Here it is 2.29. So they are not the same. So we need to proceed until we get the same answer. So now we'll just substitute for n equal to 3. So only 2 you show the working. Afterwards, you can just directly write out our answer. So we get it as 2.2890 we get. So now when you round it for 2 decimal places, this answer is 2.29. Here also we get our answer to 2 decimal places as 2.29. So the answer has got repeated. So therefore, the value for x will be equal to 2.29, correct to 2 decimal places. In case if it was not repeated, then we'll go for the next value. We take n equal to 4. Even then, if the last 2 values are not repeated, we go further until we get our last 2 answers repeated. Then that will be our solution. Now in our last part, we need to find the exact solution for x. In order to find the exact solution, this equation, we are removing all the subscripts and writing it as x equal to 2x over 3 plus 4 over x squared. Now let us take the LCM for it. So it is 3x squared is the LCM. So this will give us this x squared when you multiply, it gives x cubed plus 4 times 3 is 12. Now cross multiply it. 3x cubed will be equal to 2x cubed plus 12. So now shift it to one side. 3x cubed minus 2x cubed will be equal to 12. That means x cubed will be equal to 12. X will be equal to cube root of 12, which is equal to 2.29, correct to 2 decimal places. So when we cross check, see previously also with the numerical solutions, we got our answer as 2.29. The exact value for 2 decimal places also 2.29. Thus, using numerical solutions, it is easier to find out the required solution. Thank you.